Hello. Got a question about Chapter 8, Question 8, and so I'm going to show the A and B answers, and I think that'll show the basic idea. I did want to do this Khan Academy style with a paint tool, but I tried it, and I think Khan must have a tablet with a little pen to draw with, because it's really hard to show these problems with using a mouse. So just going to have to use a little sketch here to do it. All right, question 8 says 8A through 8D are based on the distribution of scores for a normal curve with x bar, the mean, being 75, and standard deviation equals 6.38. Draw a small picture to help you see what's required. Well, that's good advice, and even if they didn't give that advice, I'd always suggest to draw a little curve, a little diagram for yourself with these kind of problems. All right, so the first one is, what's the probability of the score falling between 70 and 80? And although this question has two parts, I think they kind of purposely made the first one a little bit simpler, because when you get a z-score, the interpretation of that, when you look it up in the table, is the percentage between the mean and that score. And so they picked two scores that are on equidistance from the mean to kind of make that concept easier. Then the later problems get a little bit trickier. All right, so with that first problem, here's my curve. All right, so you see in the middle there, I've got the mean set at 75 and the standard deviation is 6.38. So 70 and 80 are both 5 from the mean, right? And if you divide 5 by the standard deviation, 6.38, you get z equals 0.78. In this case, it really doesn't matter if we're talking about positive or negative because we're talking about percentage under the curve, and it's always going to be positive. All right, so if you look up the z-score in the back of the book on page 638 or 368, a z-score of 0.78 represents 28.23% of the area under the curve, and that's between the mean and that point, right? And so you've got that on both sides of the mean, and so you add those two 28s together, you get 56.46%, something like that is the answer to 8A. All right, 8B is, what is the probability of a score falling between a raw score, what is the probability of a score falling above a raw score of 80? So really, the only thing about these problems is making sure you have the right part of the curve. So here I have 80, and again it's 5 points away, so I don't really have to do any new calculations. I already know that the area of the curve between 50 and 80, between 75 and 80 is 28.23%. I also know that the rest of the curve below 75 is obviously 50%. And so I add the 50 and the 28 to give me 78% is below 80, and then the rest is above 80, which comes out more precisely to 21.77% is above the point of 80. Right. So I'm not going to do questions C and D, but I'm just going to look at them quickly. What is the probability of score falling between a raw score of 81 and 83? Here, like I said, they get a little bit trickier. So you have to calculate the percentage from 75 to 81, and then also the percentage from 75 to 83 by getting those two z-scores. I haven't done the calculations. But whatever they are, you're just going to subtract the 81 percentage from the 83 percentage to get that little slice between. And again, I think drawing a curve is the answer to picking the right part of it. Label the curve according to which portion and what percentage that portion represents. D, what is the probability of the score falling below a raw score of 63? All right, so for that one, you're going to calculate the z-score for 63, the percentage between 75 and 63, and what's remaining is going to be 50% of the curve minus that low slice. All right, hope that helps, and hope that the holding up the pictures to the video was good enough to see what I was doing. All right, see you Sunday.